Okay, so you can access the syllabus in this class by go to content. First of all, I'm assuming you guys are really computer savvy, or at least technical. Your technical level is above someone from math departments or something. So I was just gonna go quick on this kind of things since I assume you guys know most of them already. So where is it? So that's a textbook that you're supposed to have. It's called Introduction to Java Programming and Data Structure. To be honest, you don't really need to spend money on that. You can buy it if you want, but I mean, let me say it this way. There will be reading assignments, but I don't know if I agree with them or not. Oh yeah, they're reading assignments. So yeah, I guess you do need a book, but you can just get a PDF or wait, I'm recording. So you can go always get a PDF from Google or buy or whatever you prefer. I would prefer buy it, but you can get it for free and get it for free. So this is the book. And for your assignments, we use the thing called, I don't know how to pronounce it. It's called Replit or whatever. That is where you submit your assignments, coding assignments and stuff like that. I'll walk you through how to create, how to join the teams that I have in there. And for this class, we need JDK version 8 or above and Eclipse IDE. In the book, you have the book, it's a prefer NetBeans, but I have never come across anyone working in the field that actually use NetBeans for Java. Maybe they use it for C++ or C# or something, but not Java. So don't use it. Use Eclipse. I prefer that. But you can afford it. You can always use IntelliJ and something more premium. But for now, Eclipse should do the job. And I guess you can read through all this on your free time. Not really that important, I guess. But where is the thing that I want to talk about? Yeah, grading. So there we read assignments, quizzes, labs, assignment, projects, and is an exam. Okay, there's no exam. So the reason why I'm not too familiar with this is because I copied this class from someone else, and almost every class in the department have the same structure anyway. So there will be 10 reading assignment, 10 classwork, 10 labs, 1 semester projects. So the total of 500 points, and 450 or more, you get an A. Anything, I guess you can read at your own time. Y'all can read anyway. So for my grade, I'll treat it as flexible as possible, because I taught math before, and I personally don't believe in grading. High grade, I mean, you won't be a better employee or something. So my goal is to actually teach you the skills and the knowledge you need to get a job. Hopefully, hopefully most of you are going to software engineers or software developers or something related to technology. So this skill will help you try to get a job, or at least if I get a chance to interview you or something, then it make my life easier. So the last day to drop with a full 100% refund is September 8th. So you drop any day before this, then you have a 100% refund. Otherwise, I think you lose by percentage or something. I don't know. But you can check with Finance A office or something like that. And I think that's all. And this is a tentative schedule, meaning that it will change based on how fast or how slow we go, but I'll reserve some time to make sure you all have enough time to do the assignment. So at least 1 week to do the assignment. So if I were to change it, if you look on the assignments or something, the dates are less than a week or something, I'll extend it to make sure that you guys have enough time to do them all. Any other question on the syllabus? Okay, guess not. It's very typical syllabus, I guess. So there's not much to talk about there. Okay, so just like I say, this class is Java. We use Java. The coding assignment is on this website, and this is a link in the PowerPoint. I posted PowerPoints on content in D2L. So you go to the chapter 1 module, you see that there is a chapter 1 PowerPoint. I'll try to post it before class, so at least you guys can take a look at it before. And one important thing is, please do read the chapters, because for the PowerPoints or lectures, I don't talk about everything in the book. So I only go over the important things I think you guys might need or might want to know, or a question or whatever. But do study on your own time. This is college, not high school. You don't need me to hold your hand through the rest of the class. So I'll talk a little about myself, but I try to teach this class in a non-programmer's perspective, because I'm not a computer science guy, but I got a job for as a software developer. So here I am teaching this class. So I'll try to show you what it looks like from the other side of the computer science. If you take all the courses with all the professors, they might have like years experience in the teaching this class in a very technical way. But I prefer to stay away from that, because I'll tell you guys why later. In this class, I try to make everything, every project or something have some kind of meanings, or at least not like pointless exercise, I guess. So I've been doing this for a couple of years now, and I'll tell you what I learned throughout my work. So you can avoid making the mistakes or whatever that I used to make. So just in case you don't know, my name is Dai, and this is my email address, and this is my phone. I prefer you not text it, but in case you just say you stay up all night doing something, just don't text me at night. Probably won't answer you anyway. But so you can schedule an appointment with me for office hours, or I can meet you before or after class. That way, if you're busy during the day or something, we can always talk after that. And then this is my LinkedIn profile. You can always connect me on LinkedIn for reference or something. My hobby is pretty typical. Eating, cooking, cleaning is not one of them. So pretty. I prefer to do anything but programming on my free time. I'm not the kind of person who pull out my laptop and start coding something when I have free time or something. I do that for 8 to 10 hours a day, and I don't want to do that on my free time. So yeah, so currently I'm a software engineer at GSX. I'm a senior software engineer over there. And I work with AWS, Kubernetes, Java, Angular, Dockers, anything that is full stacks and Java related. I have my hand on it. And I'm leading a team in India for offshore, and a team and a couple of people in US in Denver. So before that, I used to be a software engineer in Peck Health, Travelport, Colorado Judicial Branch, and a center. So for entire 5 years of my career, the only thing I do is Java and Angular. And I'm what people call a full stack developer, meaning that I manage all kind of layers of the software, a web application, all the way from setting up the server in AWS or Tomcat, all the way to writing UI code like Angular, HTML, JavaScript, stuff like that. And yeah, so both my bachelor and my master is in applied math. So the only thing that I know back in the day was MATLAB and Python. And I was kind of broke doing my master degree. So I got a job as a software engineers at the center. So and then I mean I guess I make enough money so that I don't have to switch back to being poor with math again. So I'm good with that for now. And yeah, I mean basically that's all. You want to connect with me on LinkedIn, we can connect, and someday hopefully maybe after you graduated I can hook you up with a job or something. Any other question about the class before we get started? Okay, so this slide is about you. Just like, I mean, any kind of meetings, any kind of class, when a group of new people coming together, we prefer to know each other a little bit before we actually do any business or talk about any kind of stuff. And as a software engineers, I'm an introvert myself. I'm assuming most of you are, or some of you, at least some of you are the same as I am. But sometimes you just have to get over it and talk to other people. And okay, so here are the questions, and just add whatever you want to add to it. But let's start from the top down. Let me see who's in. Okay, Zach.
Hello.
Hey.
All right, so you want me to just go through this list, name off stuff?
Yeah, this is just a suggested point. You can always talk about other things as well.
My major is game design and development. I am disabled, so I actually use a cane as a walking aid. You know, hobbies, besides playing video games, I like to read, and I like to watch horror movies. That's pretty much it, though. Other than the fact I have a dog, so.
Yep. How comfortable are you with Java, or do you know any other languages?
I'm fairly comfortable with Python. I'm pretty fresh with Java. I tried messing with it a little bit over the past few days, and it's going to take some adjusting.
Mm-hmm. Okay, thank you for that. Next one is AJ.
Hello.
Hello.
My name is AJ. I am a secure software development major. With my comfort level with Java, I actually know nothing about it. I guess I kind of know that's somewhat similar to Python, but it's depending on how you use it. So some of it's gonna be different on depending on how you like code. I also currently work as a work study for IT, so I know a little bit with technology and computers, so there's that. I know a little bit about Python because I took a class before this called Intro to Programming, so I know a bit about that. Some of my hobbies would be I play tennis and I bowl. So
But like bowling.
yeah, bowling.
Cool. Yeah, like that's fine. You don't know anything about Java, or even you know a lot about Java, because when I first got my first job at a center as software engineers, I absolutely know nothing about Java. I didn't even know how to create a class in Java, and somehow I managed to land a job there. So so you are way ahead of me at the moment. So that's good for doing that.
Nice.
Next one is Alexi or Alex. I'm sorry if I mispronounced your name. Megan?
Yeah, I'm Alexi.
Okay.
I'm studying for computer science. I've never used Java before, but I don't think this should be too terrible to learn. I've used Python and some flavors of SQL before. And my hobbies besides video games is stuff like playing guitar or cooking.
Cool. Do you clean after you cook, or you have someone else cleaning your cooking mess?
I clean after I cook.
Okay.
Clean as you go.
Nope. I like to cook, but I don't like to clean. So I always have someone else cleaning my mess afterward. Next one is Autumn's Goldsmith. How do you pronounce your name?
Autumn, you had it right.
Okay, cool.
So yeah, my name's Autumn. My major, I go back and forth between cybersecurity and software development, still trying to figure out really which one I want to do. I did the beginning of the year take a processing class as well, intro into programming or something similar to that. So I kind of have a good idea, but other than that, not the greatest idea of Java or programming languages. But hobbies, I really just mostly work and play taekwondo or do taekwondo, and I go to my brother and sister's games, softball games. So that's what I do.
That's not fun. Ben. Someone's playing video game. Is that your introduction, Ben? So you like to play video games? I wonder what kind of game that is. Probably an action shooting game. Anyways, I guess you're too busy playing games. Is that right, Ben? Or was that someone else? I'm sorry.
It sounded like Battlefield. That's what it
Yeah.
sounded like.
Or Call of Duty. Okay, so I'll skip you then. Brandon.
Yes, sir. Let's see. I am a returning student. I'm a stay-at-home father. Kids are getting older. I was electrical engineering, the computer engineering emphasis before I had kids. I'm going back to school for physics because I never picked up an engineering book in the last 12 years of not being an engineer. And then for whatever reason, all my credits evaporated. So here I am. So this was like, I guess 15 years ago, 12 years ago. It was C++ and then like Visual Basic. And then I just did Python last semester and then Java. Here it is again, but I expect to do fine in this.
Yeah, it should be very similar if you already know Python.
Yeah, I liked it.
That's good. I mean, with the engineering background, I'm pretty sure you're really familiar with Python, since that's used mostly for math and stuff like that.
Yeah, no, Python was like what I dreamed of when I was doing C++. I'm like, hey, this should do this thing. And then now it does. It's actually really nice.
Let's go. Next one is Brandon. He's here. I saw him. Okay. I think you muted. Okay, he froze now. Either he froze or my internet froze. I'll skip him. Go Corey.
My name is Corey. My major is secure software development. I don't have any experience with Java, but like a lot of you, I have some Python experience. And other than for hobbies, I mean, I work a lot and I attend classes, and that's kind of about it.
That's almost everyone hobby, right? Go to work and
Yeah.
okay. Daniel.
Good afternoon. Again, my name is Daniel, and for my major, I'm doing computer networking. So as everyone knows, all networking is pushing to software. So I kind of want to bridge the gap between software and networking. As far as Java goes, for the intro to Java or intro to computer science, we use Java. So I was looking through the book, and the syntax looks pretty close to what we were doing in our intro class. As far as hobbies, really right now, I'm just taking my dogs to the dog park.
That's it could be easy enough, I guess. The next is Daniela or Daniel. Have two different names in here. There's another one's Strenton or S.
Yeah, it's Danielle.
Okay.
So I'm Danielle. My major is computer science, and I'm pretty comfortable with Java, Python. I come from a family of computer scientists, so if I don't understand something, I'm always like, "Hey, Dad." Yeah, so I know Python, I know Java, and then hobbies. I have a cat, and I like drawing.
Okay. Next one is Garrett.
My name is Garrett. I don't have a major right now, but I'm thinking of going into either cybersecurity or software engineering. I have no experience with Java and a little bit with Python, and that's about all it goes for programming languages. My hobbies are snowboarding and reading, and exercise. That's about it.
So what are you doing in the summer when you can snowboarding?
Oh, I go camping. I forgot to mention that.
Okay. Or you keep yourself occupied throughout season then. Next one is Ian.
Howdy there, guys. I'm Ian. I'm concurrently enrolled at a high school and here, so I don't have a major picked out just yet. Just like yeah, but I'm thinking about going into probably cybersecurity. That's what it's looking like. For hobbies, I just like to play a lot of games, and if that's not working out, then I jog whenever I'm bored. Same with play some music, but that's about. Then as for Java, I've had like little to no experience with Java. I had like a class back when I was like 11, I think. Then obviously I've taken a bit of intro to Python earlier as well, so I know my way around that.
You started very early then. You're what industry people are looking for, 10 years experience when you're 20. So you'll do well. The next one is Joseph. Let's do Joseph, so whoever want to go first is fine.
I can go. Heyo, I'm Joseph. I'm here for cybersecurity as well. As far as familiarity with Java, before Intro to Programming, I was in a class that taught it, but that was like more than a year ago now, so we'll see how much I retained. And for hobbies, I play trumpet and I do like other music stuff over the summer.
Cool. The next, Joseph.
Hello, my name is also Joseph. My major is cybersecurity as well. I am brand new to Java, but I took a Python course last semester, and I currently don't really have any hobbies. It's mainly occupied with working at a charter school as their IT person.
Okay. Who else? Spencer.
Wait, it didn't work. Okay. Hi, I'm Spencer. I'm also concurrently enrolled at a high school, so I'm going to pick on Ian because I know him. I do have a major. It's going to be computer engineering, and I'm not really sure about Java. I haven't done it very much, but I've done Python last semester. I think most of us did, and I don't really have any hobbies other than playing video games. Maybe throwing money at stuff.
That's a good way to. That's a good hobby if you have a lot of money. So Next one is Paul.
I'm currently majoring in computer science, and I haven't really messed with Java whatsoever. Maybe a little bit of JavaScript, but that was a while ago. Otherwise, like pretty much everyone here, I'm comfortable with Python. I've also messed around with a little bit of R. And some of my hobbies include cooking and biking.
Cool. Scott? Yeah, you already got Scott? You muted. Still muted. Nope, still muted. I think you're not connected to audio. Okay, let's go to Nicole while Scott tried to figure it out.
Hi, I'm Nicole McGelly. I'm thinking of doing creative tech. I think I did Java like in high school in like 10th grade once, but I think I know the basics. And my hobbies are doing like art and animation, and I've recently gotten to skateboarding, which has been fun.
That's nice. Tiffany?
Hello, I'm Tiffany. My major is computer science. I'm not an expert in Java, but I know the basics. And my hobby, I don't really have hobbies right now, but I do enjoy staying home, like watching movies or just doing pretty much nothing and just being on my phone.
Oh, that's a good hobby. Spencer, do you have your, Scott, do you have your audio back?
That better?
Yep, I can hear you now.
Oh, okay. All right, now hold on. Now I can't hear you because I have to turn this off. There we go. Okay. My name is Scott. My major is secure software development. I have never used Java, but I've used JavaScript, I've used HTML, CSS, Python. I've made one small little project on my spare time with those languages and Flask. I use the framework Flask for that. And my hobbies, definitely video games, and I am a firearms enthusiast, but I am not a gun nut. There's a difference.
Yeah, it's mean that you have 10 guns instead of 20.
No, I only own 3. Only own 3.
Nice.
So, yeah, but I fiddle with them. So, and that's it.
Very cool. Nicole, I'm not sure how I know how to pronounce that. Nicole or Nicole?
There we go.
Your name spell like Nakul. I have no idea how to spell your first name and your last name. So if someone can help me with his name or her name. Okay, I can hear you. So Ben Johns, are you still playing games?
I fixed it. It was using my output, my audio output. Anyway, I'm Ben Jones. My major is game design development, and I don't know Java, but I know Python.
Cool.
And my hobbies, I used to snowboard, but I don't anymore. But I like to swim. Sorry
Brandon?
about that, though.
That's fine. Brandon, are you back?
Yeah, I'm back. I'm back. Yeah.
Okay, you want to tell about yourself?
Yeah, I'm Brendan. I'm majoring in video game design and development. As far as languages go, I used to be pretty good at C#. I'm really good with Java. I know some SQL, stuff like that. I've done some stuff in Unity. I've done loads of stuff with GameMaker, of all the things. I got pretty good with their specific programming language. And then my hobbies besides video games are music. I love music. And I also collect Transformers. So yeah,
Nice.
that's me.
Okay, so did I miss anyone else?
Yeah. I
else?
had just been Daniel S. I messed that up. So I'm Daniel Stansberry.
Okay.
I don't have a major quite yet. I'm just getting back into school. I actually currently manage a team at a Target. I have done some work in C++ several years back, and I took an introductory class on Java last semester. Hobbies, really like to go camping and take our pets on walk. We have a dog and a cat, and we take them both on walks with us.
Nice. So I was curiosity. What is software, secure software development? What is that major? What is it about? I heard a couple of you have a major in that.
It's can you hear me?
Yeah, I can hear you.
It's an associate's degree. I don't know what the difference between just regular software development and secure software development. I'm sure there's going to be some sort of there's going to be another class on that.
I'm pretty sure it's just one of them it has the word secure in it. So obviously it's similar to cybersecurity, but for secure software development, you kind of develop softwares that obviously secure your guys' computers and such as that, or like applications such as that.
So regular computer science are not secure. They don't develop secure application, I'm assuming. only with the ones graduated with. That's cool. I mean, all of you are ahead of me. When I was your age, I guess that was like 20, 30 years ago. But anyways, yeah, welcome to the class. And what I was about to say. Yeah, I mean, all of you should do well in this class. And for my expectation for this class, obviously, I used to mentors and I shouldn't say tutors, but I used to mentors and work with a lot of interns in my other companies. And now I'm leading a team in India. So I mean, obviously, I don't treat you guys. I hope I don't. I have I try not to treat you guys like as students. I try to treat you guys like I'm a co-worker. So so I was assuming if I were to say something or whatever, and you have any question on it, feel free to just interrupt me. I don't care. I mean, that's how it is in a meeting. And I will expect the professional from you guys as well. I mean, you don't go to work and then I guess not finish your what you were assigned to do, and you still expect to get paid, right? So I expect you guys to do your work, and whatever assigned is, just treat it as like obviously you guys don't get paid to do this. You guys actually paid to do this. So but in the long terms, is will help you guys land a better job. And I hope you guys already know how much money you will make going to this field. I guess that's the biggest motivation for most of you guys, right? At least for me. The reason why I didn't switch back to math, even though my degrees are in math, is because the money. The money for math sucks. I started teaching middle school as a math fellow. I don't know if you guys know anything about it, but basically just free slavery, I guess, because they pay you like $20,000 a year, and you work the same amount, 8 hours a day, I guess. So after that, I told myself, never again I'll do math for a living. So because it sucks. So here I am. So congratulations for choosing the correct field. Cybersecurity, software engineers, whatever it is IT related. You guys should do well, and should be have a finance shouldn't be an issue in your future. So every time I teach a math class, I told my student to change the major, and the department does not like that. So I can't tell you guys the same because you guys are doing the right choice right now. It's not because I'm teaching it, but because you guys are actually doing the right choice in terms of monies and futures, I suppose. I mean, there's a lot of cybersecurity in here, so maybe I can get a couple of my cybersecurity colleagues to come in and talk about what they do for a living. I mean, what they do in their job, the dailies and stuff like that, and some network guy as well. So I tried to get some of their time so they can talk to you guys about what it's like to be one of them. I can tell you what it's like to be a software engineer, but I can't tell you what it's like to be a cyber security officers or security analysis or something like that. So that is the plan for the future. But for now, if I think I missed one person for introduction. I don't want to left out anyone. Nicole.
Oh yeah, sorry. That would be me. So what happened was my system preferences had me quit and reopen because I didn't allow microphone privileges.
Oh.
So my name is Nicole. I don't even know what my major is. I'm in undergrad, so I just chose something random 3 years ago. I'm pretty good with computers and technologies. Sorry, technology, but I hate Java. That's why I'm here, to learn it. So I learned Python because I'm like, okay, you know what, maybe I can learn Java with this, even though they're completely different. And my hobbies would be chess.
Chess? I'm always sucks at that. So how do you say your name again? Nakul?
Nicole.
Nakul, like cool?
Oh yeah, sorry. Yeah, that's how you pronounce it.
Okay, cool. Anything else before we get started?
Yeah, how did you manage to get a job as a software developer with no real experience?
So long story short, I like my way through it.
Okay.
I mean, technically, I did in my master program. I did a project, 2 semester long projects about facial recognition and facial detection, written in MATLAB.
Okay.
But if anyone know about MATLAB, or it's pretty similar to Python, but it's just like a procedure language people use for solving problems. So yeah, just like I lie my way through it. I didn't say lie my way through it, but I told them that I know a little bit of Java, but in reality, I know nothing about Java. I took a computer science class as part of my bachelor degree in my 2nd year of college, and I got a C in it. And yeah, just like cool. I hated Java back in the day, but now I'm using it to make money. So I guess you kind of get what you hated. So. Yeah, I mean, because the company is very their structure is that they like to hire a lot of entry level, and they have a really senior developers mentoring those entry level guy, because it's always cheaper to hire entry level than actually experienced people. So
right.
So that's their strategy. Hire a bunch of people with entry level, have a really good Java guy guiding them. So that's how they get money.
Okay.
Yeah, so I guess you are ahead of me in terms of knowledge, and I'm pretty sure some of you will be, most of you will be better than I am in the futures. And some of you can work for Google, Facebook, or whatever. They are never my my dream to work for any of them, but I'm pretty sure it is the dream for some of you. So hopefully that will come true. Any other question?
Yeah, what you eating there, Brendan? Ribs.
Yeah, I'm eating ribs.
I haven't eaten dinner yet, you know?
Yeah, it's dinner time, dude.
All right. Awesome.
Wow. So happy hours or something. But I guess some of you are not old enough to drink, so forget about that. Anyways, any other question? Okay then, let's get started with this class. And I'll try for this class. I'll try to make it not as technical as possible, because basically programming is. I guess we'll talk about it. But so my first question to when I first started was like, why do I even need a programming? Why do I want to program in life? What the hell? What's the point of it? And the first thing people told me is like, why not? Because just like some of you guys, some people actually enjoy programming for hobbies. And I'm not one of them, but one of you guys are, and a lot of people are. So I'm just checking the messages. And someone, I guess I'll talk about it after I'm stopped recording. By the way, please put your name on the chat so I can have attendance. I forgot to do that from the beginning. You can type your name in the chat, and so I can. Otherwise, they might drop you by the census day or something. So, anyways, why not? I mean, the first answer is why not. Those are the one who like to program. That's what I will tell you. And the second one is it's make our life easier. I mean, when you think about technologies and programming, always go hand in hand. Most of the technologies are hardware, are made of hardware and software. Without software, hardware is just like a tool. It's kind of useless. And without hardware, software have nothing to run on. So that'll make our life easier. That's why your phone, your computers, every video games, everything that you can think of is built on top of software and hardware. So obviously it'll make our life easier, and it's eliminate like a repetitive and boring task. For example, if what I like to do is normally if someone were to tell me to do something really boring or something, I would just write a little softwares or a little program or whatever it is to do it for me, so I don't have to do it 10 times. And I hate to do the same thing over and over again. So that's how that's why motivate me to do any of that. Because the computer doesn't complain if you tell them to do it 10,000 times or a million times or something. It's more than happy to do whatever you tell it to do. And the last point is to make our job easier and tasks more efficient. So back in the day, even simple thing like look up something on for your class or some information, you have to go to the library, open a book, or ask the librarians or something. But nowadays you can just search for take you 5 seconds to search for where you need to search for. So when you think about it, the technology behind it is really is kind of how this works, kind of thing. You guys were born, most of you are born in this era. That's why you don't see significant of it. But back in the day when back in 2000 when the website or whatever it wasn't that popular, then you guys see the pain of looking for some information or something. So now we know why do we need programming. The next question is, what is programming? So programming is basically from the bottom line about programming is just writing. It's like writing an essay, basically. It's writing a letters or writing a short paragraph. You have to follow certain syntax, and you have to follow. You have to use a certain vocabulary, just like you write an essay. I mean, when you think about it, programming, you just put a bunch of letters and word together and somehow make it work. But just like essay, I guess. You can put word in random order and it doesn't make any sense. The same thing in programming. You have to actually follow a certain grammar, syntax, and stuff like that for a program to be understandable by humans, by machine. Just like I say, programming is basically just composed of word and sentence. A high-level language like Java or C++, it has it's really easy to understand, and you can basically read it and understand it easily compared to like assembly language or binary or machine language or something like that. So in a program, there's a thing called sequence of instruction or statements. Basically, it just executes statements after statements in orders. And most of the program will execute in order synchronously, and some of them will execute asynchronously. And Java is one of the guy who actually, one of the language where it's execute from top to bottom or in sequence order. So there's a couple of different types of languages. The first one is machine language. This guy is basically just 0 and 1. When you read it and when you look at it, it doesn't make any sense. Even someone with 20 years or 30 years experience, they look at the binary machine language and they have no idea what the hell that thing is. It takes some time to understand it, and actually it's kind of pointless for a human to look at it. And the next one is assembly language. Back in the day, when we first invented computers and processors and stuff, some guy was like, hey, I have no idea what the hell 0 and 1 is. Kind of hard to read. So he came up with some kind of, they, or I don't know who the hell come up with it. Not a big deal. The thing is, you have to know, all you have to know is assembly language basically a little bit easier to understand than machine language. It used simple word like add and stuff like that. But basically, all these languages, assembly, high level or low level, whatever it is, will always need to translate into machine language. So machine language is the bottom line. Assembly language, even though it's a little bit easy to read on 0 and 1, it's still a little bit hard to read. It takes forever to do something simple like print out something on the console or adding or subtracting, and you have to manage the memories and stuff like that. And I think back in 19-something, some guy came up with Java, and before that, some guy came up with C++, C#, C, and stuff like that. Basically, it's easier to read. That's when the software languages and software developer get to grow, I guess. Because if I were to look at assembly language and machine language, I probably don't want to do anything to it, or I don't want to have anything to do with it, regardless how much money they pay me, because it's kind of like it looks very painful to program, unless you're really into it. So high-level language is a little bit easy. It's really easy to read actually. It's human friendly, but not pet friendly. Just don't keep your pet away from it. And just like assembly language, you still need to compile into machine language because computer doesn't know what if is. It's only knows 0 and 1. So basically, we convert all that into machine language. For high-level language, there are two type of they use two type. There's first one, a compiler, and the other one, interpreter. Compiler means you have to compile the code, and you have to compile the source code, and then the source code turn into bytecode or whatever, and then it's going to execute on the machine. And interpreters is Python, for example. When you type 2 + 2 on the Python console, it's going to output the answer directly. It doesn't need to compile or anything. So that's the difference with them. Again, you can read in the book. I'm just going to go over the main points because vocabulary is always the worst part. Like I say, compiler compiles source code into machine code file, and then it gets executed on the machine. Interpreters interpret each line of code and execute immediately. If you take Python, I'm assuming, I mean, I heard most of you already took Python. When you type in the console 2 plus 2, and the Python console is actually immediately print out 4, because it is interpret each line by line, and it's execute directly immediately. So just know that Java, C#, C++, they're compiled language, and Python and MATLAB or whatever are interpreters of language. Okay, so in Java, there's any kind of every time you go for any kind of Java interview, Java job interview, they always ask you what's the difference between JDK, JRE, and JVM. And basically, JDK is just a collection of toolkits that we use to develop Java application. It contains JRE as well. Every JDK comes with JRE built-in, and it has a lot of tools that we use to develop, like debuggers, compilers, and stuff like that. So basically, Java JDK stands for Java Development Kit. It's, as the name implies, it has everything we needed to develop a software, a Java application. JRE is stand for Java Runtime Environment. Basically, it's including everything that we need to run a Java application, like libraries, loaders, JVM, and this is part of JDK. So if you're a developer, you might want to download JDK. If you just want to run a Java application on your computer, then you just need to download JRE. JVM stands for Java Virtual Machine. Basically, this is where the magic happens. Is translate Java bytecode into machine language. We talk about why this is the reason why Java is a platform independent. But every time you talk about Java, you always talk about the main benefit of it is that you can write code once, and you can run it in any kind of platform, operating system, or a computer or machine or whatever. It doesn't distinguish between, you don't have to write different code for different operating systems, basically. That's the magic of Java. C#, C++, you have to compile them and all kind of things. It's a mess. So why is Java platform independent? Platform independent basically just means that you write code once. Let's say you write the same Java code. The Java code, when you write Java code, you write once, and it doesn't really, you don't really write it specifically for any kind of operation system or any kind of CPU or anything like that. You just write it once, and then you compile it, and then you execute on any kind of platforms. So basically, in here, you have your code. Your Java code is in the .java file extension. This is where all your instruction and statements and all that thing is going to be in. And then you compile. You use a compiler to compile the Java file, and then it's going to turn the Java file into a .class file. So this is the Java bytecode. Basically, it looks a little bit more human readable, but it's not something you want to look at. I'll show you what it looks like later. And then with this bytecode, we take this bytecode, we run it on different JVM. So JVM is the one that is platform dependent. Java code is platform independent, but JVM is platform dependent, meaning that different operating system or different CPU or whatever that is will have their own JVM. So your car has a different JVM than my MacBook or someone else Windows or something like that. So each of this JVM is a different, it's built different based on whatever is used to run on. So so that's why Java is platform independent, but JVM is platform dependent.
Okay, I got a quick, so like my computer already has a JVM in it that I did not have to put in there, pretty much.
Did you download and install JDK?
I did not know.
Okay, then we go through it. But basically, JVM come inside JRE,
Okay,
and JRE is part of JDK. So so basically, what you need to know is as soon as you install JRE, JVM is coming with it.
okay. So I guess, so, all right, so you're saying just for writing the code and running it, you have to have a JVM specific for, right, JDK, John?
Yeah, so to write code, you need JDK.
Right.
To run Java file or Java class or Java application, you need JRE.
Okay,
So as a developer, you never download JRE because you might want to develop in Java, right? So you download JDK, right?
okay,
So when you download JDK, you have JRE and JVM come with it.
okay. And you have to tell it, when you download it, obviously you're going to be downloading it for your operating system. So Java Virtual Machine will be for your operating system.
Yep, that's why it has different version. I mean, different operation have different JVM. That's why when you download, it gives you option of all the different operation system you can download from.
Okay.
Because this guy right here, everything else is the same except for this JVM. JVM is different based on the operating system. Good question. Any other question before we move on? Okay, so the next question is why Java? I mean, why not C#, C++, Python, or JavaScript for that matter? I mean, there's no particular why Java. I mean, you can pick anything. But normally, if I were to pick an application, I mean, a language, and I know, so this is the question normally people ask when it comes to like architectures discussing before we actually start an application. So anytime you start a new project or a new application for any company, the first thing they'll ask is which language do you want to write it on? It's really depend, right? I mean, if you want a web application, then either Java or Python will be the best, will be ideal for the backend. But you want to write a math application or something that require better memory management or performance or anything like that, then you choose C++ or C# or something like that. But so it's really depending on what your use case is going to be. And so normally Java is always the top of the mind when they think about writing a web application or something like that. Nobody write Java for, I mean, you barely see any Java software or Java, I don't know, like Photoshop or something that nobody write Photoshop in Java. It's kind of like not the best way to do it. Okay, so Java is really popular. It's still popular now, even though people keep saying it's dead, it's dying, and all that thing, but it's still very popular. Most of the web application you see is built on Java, and some of the Android app is still written in Java, even though they try to switch to Kotlin, which is basically just Java, but in a wrapper language. So you want to learn Kotlin, then it's better that you know Java too. So you're into Android development, then Java and Kotlin is the way to go. And I mean, when something is widely used or has a huge audience or user, this normally come with a huge community. So basically, any problem that you have with Java or writing code with Java or whatever you have related to Java, you can just Google it, and that will be like hundreds or thousand pages of answer for you to look at. So you never have to worry about not be able to find what the issue is or how to solve it. Just like I always tell everyone that not into programming, when they ask me what I do at my job, I just tell them I Google most of the time. I Google 80 or 90% of my job. Not because I don't know how to do my job. It's just because I don't want to spend hours trying to figure out something that someone already figured out. And so that's a huge benefit of it. If you were to do something with less popular, then it's really hard for you to actually troubleshooting or fixing the problem that you might have. And it's really easy to learn. Anyone with any kind of background or any experience can pick up Java really easily if they follow certain syntax rule and grammars and stuff like that. It's very easy to pick up. And you can, I can't tell from my experience because most of my experience are in microservices and developing web application. I use Java for web application and just for RESTful services. So that's the only thing I know Java is used for, because that's all I use it for. So in Java, you don't have to worry about manage the memories, because Java have something called garbage collectors. It will go and collect all the basically in the simple term, it just go and clean up the memories for you. In C++ or something, you have to actually manage the memories allocation, and have to actually remember to delete those allocation. Otherwise, you're going to run out of memories very fast. So Java is just basically it just compile once and run everywhere. So you wrote the whole application, the whole Java application, you compile it and you give it to someone else, and they can run it on any kind of operating system or infrastructure or anything. You can even run on microwave if you wanted to. But given that you have the JVM for it, Java is case sensitive. I would say it's widely used. It is object-oriented programming language, and we talk about it later, but it's not 100% object-oriented program language, and that's the reason for it. It is high-level language, meaning that it's really easy to understand and it's really close to human language. It's strongly typed language, meaning that every variable you declare, it has to have a type. Unlike Python, you can just say, in Python, you can just say a variable equal to some numbers or some strings or something. Then Python automatically know what type of variable that is. But in Java, you have to declare what type of variable that is before you can actually use it. Otherwise, you're violating the grammar rule or syntax rule. And it has a really strict syntax rule. I guess all the languages, except for JavaScript. JavaScript is very flexible on when it comes to syntax. I saw someone wrote the whole application, or at least a very simple application, and store inside one variable and execute it from there. So it can be a mess. That's why I prefer something that is strict, like Java or not JavaScript. JavaScript is never my favorite. So basically, oh crap. I forgot to show you something, but I guess I will show you after the break. So normally, Java basically just every Java application needs to have a class, obviously. Otherwise, you cannot have any kind of code or any statements or anything like that. So in Java, a class representing the real world object. So if you were to write a bank application, then one of your class should have something like ATM or a branch or something like that. Something that representing the object in the real world, like a machine or a person or a door or anything like that. So that's why it's object oriented. That's why we call it object oriented, because we code based on the objects representing the object. So a class can be declared using the keyword class. Keyword in Java basically are just reserved words that you cannot use, and it has certain meanings to Java. So I'll show you a couple examples when you go to the when we go to the hand-on section. And a class in Java can contain multiple variables or methods or function. How this depending on whatever you call it. If you're familiar with Python or something, you call them functions, but in Java we call them methods. So I prefer the word method more than function, mostly because methods are mostly actionable. We write method based on the action, each person action, the action that we can take in real world, an object can take in real world, like deposit money or withdrawing money or something like that. So in Java, a class is just basically just a blueprint of instructions. If you know what blueprints is, basically it's just a sketch of let's say of a car. I guess when you think of it, like a car, a blueprint of a car. I guess it shows you how to build a car, but it's not actually a car. So we'll talk about why it is a blueprint, but not an object itself. I mean, we can use a class to create multiple instances. This kind of thing, I guess we dive a little bit deeper later, because right now I'm just telling you what a class is in Java, and we show them what a class actually is when we actually programming. And when we get to the section where we talk about classes and stuff like that. Just like I say, keyword in Java are reserved, which means that you cannot use the same keyword. Like for example, class or public is a keyword in Java, and you cannot name your variable class or public. That's basically it. And I mean, that's a long list of them, but basically you'll never, as a programmer or a software engineer, you'll never make any mistakes by naming a variable using a reserved keyword. That's a mistake you will never make. So I'm not sure why people are so worried about naming reserved keyword in Java. Is all of them I think all of them are lowercase. So they are lowercase, like public, statics, private, long, double, int, stuff like. There's a bunch of more, but they're in the book if you want to look at them. And eventually we go through some of them, not all of them, because that's a lot of things that we don't even care about in Java. So I'll try to go through some of them, or at least most of them. If you use any kind of IDE, IDE stands for integrated development environment, something like that. So basically it's like Eclipse, IntelliJ, NetBeans, or whatever it is. It's kind of help you developing your application. And the keyword will be in different colors in IDE. So you will never miss them. That's why I said from the beginning that you will never have the mistake of using the keyword as a variable names or something like that. Because the compiler will yell at your face if you were to do any of that. And if you commit any of that to the repositories, then your coworker will yell at your face and your boss will yell at your face. So in Java, a Java class always have the same structure. Almost all of them will have the same structure. Remember, I'm talking about class right now. I'm not talking about interface or abstract class or anything. We strictly focus on class. So a class can be declared by using the keyword class, obviously. So this keyword right here is what tells Java it is a class. And every file, you notice this right here, this file name sandbox.java has the same name as the class name. So the class name much match with the file name. So if you name this guy, let's say person, as with the uppercase .java, then your class name better be person. So it's gonna be public class person. As you notice, the first letters is always capitalized in the class name. I mean, you can put a lowercase person. The Java, the compilers or IDE will still let you compile it and stuff like. And but the problem with that is they can make you look like an idiot if you were to just type person with lowercase. And all the people won't take you seriously, and they probably won't renew your contracts or something like something in that nature. So try the first letters should be uppercase, and so basically inside a class, after you declare the class, the keyword followed by the class name, and you notice there's a little curly bracket at the beginning, and there's another curly bracket at the end of it. So this tells Java where the class starts and where it ends. In Python, I guess some of you already took Python. So in Python, the class, do you guys talk about class in Python or objects? So in Python,
Not really.
Okay, then I won't talk about it.
A little bit.
Okay, so syntax in Python is a little bit different because you actually have to tap in, everything has to line up with the tap. But in Java, it doesn't have to, but you want to. You don't, the compiler won't complain about it, but your boss or your coworker will complain about it.
Pretty printing.
What was it?
Pretty print on most compilers, I think.
Yeah, but yeah, you can use the auto format, but before you actually use those built-in function IDE, make sure that you actually follow this consciously, not just let the IDE do it, because sooner or later you have to code in front of people, and the last thing you want is to write everything on the same lines, especially during the interview or something like that. It's gonna make you look really bad. So yeah, so body of class is enclosed between the open curly bracket and close the curly bracket. Don't forget this because this tells Java where to start and where to begin, where is begin and where is end. Otherwise, when you think about it, without this guy, you have absolutely no idea what's inside of sandbox class, what belongs to it and what doesn't belong to it. So it's not just best practice, but it's required to have these curly brackets in there. And I assume that most of you guys don't have the JDK installed yet, right? It's okay.
Not yet.
Okay, there will be a hand-on section where we set up our environments in a couple of slides, and we start from there. And because I mean, programming is like math, doing math. You can watch me doing it for like a million times, but when you actually your turn to do it, then your hands are sweating. And what was that Eminem song where it's like it started, your hands are sweating and palm or whatever that thing is. So actually,
hands weak, palms are sweaty.
Yeah, I should have played that song every time I talk about it. But so basically, it's best for you for your own benefits, because I mean, I already know all this, so I don't need to do it myself. But for you as a beginners or as someone who learn new things, it's always best to actually do get hand on and play around with it to see what's wrong and what's right. So I'm talking about creating, compiling, and executing report. So basically, you are working, most of your class is called source code. Source code is where you write code directly, and that is where the file is most readable. So in here, you can see that it's really fairly readable by human. So this is what you call source code. This is where you write your code, called source code. And this is where you save on your hard drive or your thumb drive or whatever that thing is. And then you compile the code. So this is where you compile your code, and that's why we call Java a compiler language or high level language, because we actually use a compiler to compile the code. So we compile the code into Java bytecode. So this is the Java bytecode. And Java bytecode still look somewhat more readable than machine language. So this is what the Java bytecode look like. And it has like, if you notice, it looks just like assembly or some low level language, because that's where it is. And then when you're compiling the program, you might forget a semicolons or something like that. Then it will throw a compiling errors, and you have to go back and you modify it. So this is what the diagram tries to show you. Because every time you write code, especially you don't use the IDE, and then you have to compile it manually. Eventually, you run into some compiling error for forgetting the semicolons or declaring the variable that already existed or assign different wrong type of data to the values or something. Then this is where the compiling error will happen. So when you compile the code, Java will create a new file called class name. I think it says somewhere in here. Yeah, right here. Where is it? So the class name is welcome.java. So it's going to be when you compile the code, it's going to be welcome.class. So this is the file name after it's compiled. So Java will create another class name, will create another file named welcome.class. And it's going to store in the same directories of the welcome.java. And we go through all this kind of thing so we can actually see hand-on first. So this is what you call bytecode. And then we take this bytecode and we distribute it to different environments or end users or something, and then they run it on their end. So regardless of what version of Java or not version of Java, what operating system they have, Windows 7, Windows XP, Linux, Mac, whatever, they'll be able to execute on it, and you don't have to worry about telling them, hey, you have to run on Windows or you have to run on Macs or something like that. You don't care about at the point you compile the code, you don't care how they run it anymore. You just let Java or JVM or JRE deal with it. So basically, you can run the bytecode. The JVM, the Java virtual environment, is going to run the bytecode, and it's going to produce some kind of results. In this case, it just prints out welcome to the world. So later on in the later section, we talk about compiling exception. I don't like the word errors because errors is in programming, or at least in Java, mean that it's not something that you want to deal with. It's something happened by the servers or Java or whatever caused it to happen. But I would prefer the word exception. And we talk about what's different with exception and errors later. But for now, just I guess we can follow the book and say errors for now until we get to the last part of the book. And this book, I won't talk crap about it, but all I'm saying is that this guy, I guess he write this book based on the academics, not the real world experience. So some of them are really outdated. Like he used NetBeans, which I don't even know if it still exists or not. But and there's a certain styling and certain standards that I will try to stay away. So I'll tell you when we get there. But for now, I mean, just read the book as the way it is for now. And then in the lecture, I'll tell you what to avoid and what not to avoid. So when you compile in class, you can use Java C. This is the key. This is the command on terminal, and we'll go through all this lab together. But for now, all you need to know is to compile Java class. You use Java C space class name dot Java. And when you look at this, the first time I check my directory, it just sandbox.java. But when I compiling it, like I use Java C sandbox.java, and I check the folder. Now I have 2 different files. So just like I said, this guy right here is generated by Java compiler. So we create this new file. So this is where you hand off to Tomcat servers or users or something, so they can run it on their environments. So executing a Java program is pretty simple. All you need to do is take the class file, sandbox.class or whatever the class name .class, and just run Java class name. That's it. Don't put java.class or anything. Just Java and class name. I mean, I'll go really briefly over this just because it's good to know, but nobody in the working environments, you rarely have to do any of this. You let the IDE take care of it, because you have 8 hours a day working and meeting. The last thing you want is to compiling the source code yourself. It's kind of pointless, and I guess your boss won't be too happy about it, because he's the one who paying you, not to sit there and compile the code. Because that's what the IDE is used for. I know there's a lot of things in there, but basically those are just overview. I guess it's the first week, so I guess you haven't read the book yet, or you haven't have access to the book. So I mean, you don't even need a book. Just go and search for basic stuff. I guess just any book will do it. We don't have to have this book. But I think let me stop. Pause the recording, and then I'll tell you, talk about something. Okay, so you open the chat on your Zoom. Somebody posts a PDF version. I don't know who that is, and I don't want to know who that is. And yeah, I don't want to know who that is. Technically, there's not really something I endorse, but you can download it or at your own risk. So save yourself a couple $100, I guess. Buy something nice for your dinner or something. No, download it, just open it. But you can always download it, so you don't have to keep opening it, because as soon as this class is over, or somebody take it down or something, then you can lose it. So feel free to download it, but you can download virus or you get scam or something, then that's not my problem. And let's take 15 minute breaks, I guess. We come back around 7:15.
All right.
Yeah, I'll check, but not with this computer. I don't want a virus or something, and then crash the whole servers, and then the next day I'll be unemployed. So I'll try to download it later with my my personal computer, just in case. Thank you for pausing it. Okay, so for this class, you need the account for Replit, I think that's how you say it. But I'll send you a link to join the team in chat. And for those who haven't started, you can actually join the team in there. I'll send it in the chat. Join the team in there, and then we do a little bit of walkthrough. And Cool is already start coding.
Well, I'm waiting on this. I'm waiting on the link.
It's not in the chat. Oh, I think I sent it to private chat. It's weird.
Oh,
there you go. Can you see it
There.
now?
Yes, thank you. Of course.
Okay, so let me do a little bit walkthrough for this page. This is where you do your assignments and coding assignments. So most of the thing probably like this, because first of all, just so I don't have to grade them manually. Second, so you can get used to this kind of interface, because when you actually go do a job interview, especially for a technical related job, they'll ask you to do some kind of hand-on whiteboard problems, I guess. So you see this again in your career. So it's good to get used to it, I guess. And the more important thing too is you can do this in your iPad or I don't know, in your anything that can you can open a browser with. So you have to download Java or something. If you were to borrow your mom or your brother or something laptop, you can always run them directly. So you don't have to install Java in there. Okay, so if let me go back. There is started recording. Okay, so when you first land on this page, you see a bunch of projects. I mean, not a bunch right now because I haven't published the rest yet. But you see at least lab 1.1 and lab 1.2. And if you click on any of them, it will take you to this interface, this page. And normally you have a couple of files. All the files, involving files, are on the left-hand side. And you see a main.java class most of the time, and a readme.md stand for markdown. That's a really typical file. If you were downloading any projects or something, you see a file named readme. So basically, it has instruction on what to do with this project. So for this project, at least it's telling you to ask for user input and ask for name and number classes, and then you output the values that they put in your in the console. So you may not be familiar with this enough. Actually, you may not familiar with this at all. So we go through a couple hand-on before you can actually start this. And yeah, so what I want to show you is just the basics of what it looked like and how to get there. So let's say you type something in here, doesn't really matter, you can hit run. So you see it's kind of mimicking the what happened in the background. So in here, you can see that it's use Java C command, which all you need to know is that it's actually compiling this main.java file. And then it's run the Java command with the class name, which execute the file. So in the first line is compile the file. The second line is executing the file. And hello world is the output of the file. We go into the detail as to what this is, but basically you hit run, it's just executing thing. So for example, if I were to miss the semicolon in there, the downside of this is that it's not going to tell you that you're missing something. So normally I will write them in Eclipse or something and then just copy and paste in here and run the code to see how it goes. If I were to hit run, and then you can see it's failed when it's compiling. So one skill as a developers or a software engineers or whatever you want to call yourself is the ability to read the error file, the error message. So in here you can see it's very specific about what's missing. So it's just telling you that you're missing a semicolon on this line. I think it's telling you what line this is. So then this is the name of the class, and this is the line numbers where the error occurs. So in this case, this is line number 3. So basically, according to this, you're missing a semicolon in line number 3. So you fix it, and then you hit run, and it will compile and run. So when you do this, the benefit of this is that it's actually let me grade this projects or assignment for instead of me doing it. Some of them will involve me doing it directly, but basically you just run a couple tests. This is very typical in programming or developing or whatever. There's a thing called unit tests, and we'll talk about it later. But basically, you just testing your code to see whether it's producing the desired output or not. If it doesn't, then something is wrong with your code, or your business logic is not doing what it's supposed to do, and stuff. And anything that can go wrong, you have to go back and fix it. And yeah, so this is what we call unit test, and we'll talk about it later. I don't know if in this book talk about unit test, but that's a really important part of the of a application. So you can access it, bookmark it, or whatever, but they're always in the anytime. No. So I guess it's just chapter 1. But if you forgot where it is, it's in the chapter 1 module. You can just go in there and you can see the link. You can click in there and take you directly there, or just bookmark it. Any question about this guy? Okay, so as the developers,
I'm sorry, I have a question about the on line 1 there. It says class main. That's just for like learning purposes, right? Like you don't have to put class main on line 1 on every single Java thing that you make, right?
You actually do.
Oh.
Because if without class main, you were to remove them, the first thing you ask yourself is, if I were to read this, how do I know what class this belongs to, right?
Okay.
So immediately you see something wrong there, and I'll question myself. Yeah, I know there's a main method, but what class does it belong to? Like, I mean, what is this supposed to do? There's a bunch of questions in my head, right? And if you have questions, then basically the IDE or the compiler or something will have the same question. So so it's not optional to put a class name in there. It's actually required to put a class name in there. Okay. And just like I said, programming is basically just a way, very similar to write an essay. So this guy right here is basically your name, right? If I were to grade this paper and then you have your name in there, then I have no idea who that is.
Okay.
Or missing a comma or something.
Right.
But technically, this guy should be public. I don't know why it's not public. But I guess it doesn't make a difference in here. But yeah, we go after we set up the environments, JDK and stuff like that on our computer. We go in detail, and I'll explain to you what each of this line means and what it means to computers and things like that. So for this class, I always like to have hand-on, probably because I always tell my co-workers or my students or something, you can see me doing it for like 1,000 times. If you don't do it, then you probably won't get it. So the thing is, everything makes sense when I do it, but when you actually have to do it at home or by yourself or something, then suddenly everything that makes sense to you no longer make any sense. So otherwise, we don't need a class. We can just go and do it ourselves. So the first thing I want to do is I want to make sure everyone install their JDK 8 Plus on their computer. So how many people have Mac and how many people have Windows or Linux? Does everyone have Mac? I'm assuming majority is Windows. Any Linux?
I have Windows.
Okay. Any Linux in here? No? It's a computer science class. I expect like at least 1 or 2 Linux.
I mean, I got a dual boot machine over here, but it's been a long time since I've used the other side of it.
Yeah.
I used
Yeah, I
to have
installed
a
Linux.
computer, but it got stolen at school.
Oh.
Yeah.
Well, hopefully they know how to use it. Otherwise, it's pointless to them.
Yeah.
So, anyways, so one way to check whether you have a Java or not is you open CMD on your computer or the terminal on your Mac. Can you see my screen fine? Or it's too small?
That's good.
Because I have a wide monitor.
What thing
was
was that? Sorry, I didn't hear.
I'm just saying, yeah, command line, CMD on Windows or terminal on Mac. This maybe you're some of you already have it or installed on your computer and you don't notice, or you're whatever. So let's just check. So you can check for what version or whether you have it or not by just type Java minus version. And you hit enter.
Java is not recognized.
Okay, so every time you hear the word Java is not recognized, it means you don't have it. So we have to install it.
Out of curiosity with installing it, I know that there are a couple of specific versions listed. Is it okay if we use the most current one, or should we go back to the older ones? Since I kind of wanted to avoid making an account for downloading the out-of-date stuff.
Yeah, so my rule of thumb is always go with the latest, because it's always backward compatible, but not forward compatible. So in another word, if you have Java 12, let's say mine is 12 right now, and the current version is 16 or something, right? So if someone wrote an application in 16 and they use the features that only exist in 16, mine won't be able to run it, or I won't be able to open it or something like that. But if I have 16 and someone write the application on Java 12 and use some feature from Java 12, I can run it regardless of what, right? So it's always safe to have the latest version.
Glad to hear it.
Yep. So who have Windows and doesn't have installed it? You can be the guinea pig or something. Do you mind sharing the screen so we can walk through how to?
Yeah.
Okay.
Whoa.
Make sure you close any sensitive information or whatever.
No, I think I'm good. Here we go. There we go. So this is I just did a Google search of JDK.
Yep, that works. So yeah, you mind click on the first guy?
This one right here?
Yep. Okay, can you copy that link and send you the rest in the team chat?
Yeah, the URL.
Yep.
It's actually in here. How the hell do I?
So
I gotta
with
stop. Hold on. There we go.
with Zoom, sometimes when you minimize it, it ends up putting it up in the corner and you have to maximize it from there to get back to it.
Yeah. There we go. That's for Windows though, I assume.
I think you stop sharing.
Yeah, I did. I just did that to put that in the in the thing there. There we go. All right. JDK download right here.
Yes.
Uh-oh.
Okay, so you go down, there's a bunch of them, there's a different version. The reason why they have different version is just like I say, what happened? Okay, the reason they have different version is because the virtual machine is different based on whatever the platform you're on. So if you're Windows, then just download Windows installer, the .exe, yeah. And you Mac, then just download the Mac. Your Linux, there's a bunch of different varieties. So make sure you download the correct one.
You have to accept the Oracle Technology Network License Agreement.
Nobody ever read that anyway.
Yeah, they don't even have it listed. Look, it's just the you can't even read it. All right, there we go. Opening up. Do you want this? Yes, I do. Oh.
Okay, so let's go slow so everyone can get.
Oh yeah. Here, I'll go back. There we go.
Okay, so when you open the file, you just download it. Hopefully everyone already downloaded it. And then I guess the only thing you can do right now is click next. So let's do that. You can choose what folder you want it to be in. Right now is default program files. So I guess that's the way you want to leave it for now.
Yep. Come on. Do it. Oh, there it goes.
Okay. Yeah, I don't care about that. Just get close.
You don't want tutorials or nothing? Okay.
Not yet.
Close.
You can do it when you have like you can't sleep at night or something. You can always do that. Okay, so will you mind open your terminal again? The CMD, the command line. Okay, let's close that one. Let's open a new one.
Oh, you want a new one?
Yep.
Okay.
You might have to add it to the environment and variable path. So that, but let's try. Let's do Java space minus version again.
Version?
Minus version.
Yeah.
Okay, cool. Now you have it.
Yeah, look at that. All right.
They made it easier now. Does everyone else have it installed, or you just taking a nap right now? Everyone good?
Yep, all good.
Good. Yeah, I mean, if you want success, you want to be good at what you're doing, or get promotion or something, start treating everything like you're getting paid for it. So you pay for it, so may as well get the best out of it. So let's stop that. Okay, let me share my screen again, please.
There you go.
Okay, so I'm assuming when you do that, you have some kind of version. Yours should be say, yours should say 6 point something, whatever, right?
Yeah.
Okay, so just a couple of things.
Yeah, 16.02.
Okay, if you're down the latest, I guess that's what you'll get.
There you go.
Okay, so let's try something. Before we use Eclipse, or actually let's go ahead and install Eclipse. I guess let's do it all over. I mean everything at once, then we can stop and talk about it. So you can always go and search for Eclipse on Google. And the first thing you see is just download. Normally just download it, I guess. And just like everything else, try to get the latest, the most stable one, the latest but stable. So this guy right here should do the trick. I already have it started, so I don't want to download again. But if I download it, actually, Scott, will you mind share your screen again? Or someone have it installed Eclipse? I can't hear you. I think you're muted. you still build it. I don't know if you were saying
There you
something.
go. Sorry. All right, Eclipse.
Okay,
Or-
you click on download right there. There's a link for
Oh, yeah,
download. Just click on it, take you directly there,
There we go.
and let's just download it.
And there you go. $35. I don't know about that.
Yeah.
Bring that guy down here.
After all my experience with Eclipse, probably worth nothing. I mean, it's free. That's the best part of it.
Yeah, that's true. It's a big file.
Should be like a 1
100.
gigabyte or something.
100, yeah, that's about right.
It's on the 100 and something megabyte.
Yeah, 111 megabytes. Yeah, that's a gig, isn't it?
Oh,
No, I don't know.
can't see it.
So what if we already have Eclipse installed?
Then you don't need to install it.
Okay, that's just
Yep. Or you want, you can install NetBeans, which is almost no one use it for Java. So you can be
Is it all right if we use JetBrains?
what? Oh, JetBrains, the IntelliJ.
Yeah, I've heard really good things about it.
Yeah, I'm using it. Pretty good if you pay for it.
I'll take it.
That's a free version, but that should do it, I guess, for free version. Yeah, while he's doing that, while that thing is downloading, that's the thing about IDE is that as developers, nobody ever writes code in terminal, like, you know, in the movies, hackers and all that thing, they always type random things in the text editors, and they're assuming that they hack and do things. But in real life, nobody ever do that. At least I haven't seen anyone doing it. And I work with quite a lot of people, and I guess the point here is that you use IDE to make your life easier, because coding, everyone know how to code if they know how to read Java. But the difference when a good developer and a bad developer is that the good one know how to use the tools. The bad one kind of like stuck around and try to figure out things the hard way. So I'll show you why using IDE or like Eclipse or something is a good idea. Either you have a slow internet or Eclipse is just really slow to download.
I don't know. The other one downloaded in a blink of an eye. I don't know what's going on with this.
Yeah, no, it's definitely Eclipse. Just low bandwidth, I guess.
Yeah.
Probably they need more donation for the server.
Yeah. They didn't pay Jeff Bezos their bill. Oh, is it done?
Nope.
Oh.
Yeah, that's part of why I also wanted to do JetBrains instead. I saw this install and I was like, no.
Maybe if we have time later in the semester, Scott, since you're like almost an expert in Agile and Scale Agile, you can talk a little bit about it. Because I mean, nowadays you cannot have a developer job and work in waterfall anymore. So almost everything is Agile now. Even the government try to do Agile. So yeah, I work for a couple federal projects, and they use Agile I work for state government and they still use Agile. So not Scale Agile, but just a regular Scrum Agile.
I'd be more than happy to give an overview of Agile and Scaled Agile.
Okay, here we go. Oh my goodness, this is taking forever. There we go. Open this guy up.
Okay, so you get to that screen right there, and normally the first option should be more than sufficient for this class. We don't need Java and web developers. That one down there is for like if you're developing some kind of web application or something. But this guy should be enough. The first option, Eclipse IDE for Java developers, and make sure you know where you install your folders. And I think you can choose, you have different version of a JDK, you can always choose which one to install, I guess. But for now, it should pick out the default one you have on your system. It's going to take a while, I think. All right, sorry, finished. Okay, you can launch it. Okay, that's all it is to install. Right now, let's just cancel it out. We'll talk about it after my hand-on demo. Okay, let me share my screen.
Oh,
Scott.
There you go.
Cool, thank you. Okay, so does anyone have issue installing Eclipse or for login info? Who?
Yeah, it's just asking, I'm at the same stage of the process. It's just asking for login details.
For Eclipse?
Yeah.
I just hit cancel and it just continued right on its way.
Oh, okay. Yeah, that worked. Cool.
Yeah. Anyone else have issue? Okay, so like I say, Eclipse is a crucial part of your daily job, but not now. Right now, I'll show you the reason why we have. That's the reason why we need IntelliJs and stuff like that. But if you have on your Windows, you can open a text editors. That's my new folder. Okay. Okay, so if you're on your Windows machine, just open Notepad, and on your Mac, just open text editors and change it to make it plain text. Okay, so what I'm going to do is I'm going to write some Java code, a really simple Java code, and I'll demo how to do the compiling and executing and stuff like that. So let's try that. So I mean, you can follow along, but I don't know if you can see my screen. I think I need to make it bigger or something. I usually use Windows, so I still don't not used to Mac yet. Don't know how to make it bigger. Anyways, so I'll type in, oh, big. Wow, that's great. Okay, so what I'm going to do is I'll type in public class. The annoying thing about text editor in Mac is that it's already auto capitalized. So public class, I'll name it forward. I guess not the best way to write in this guy. So to execute a Java class, right now you don't care about much about it, but it's gonna be public static void main. Don't worry if none of this makes sense. It shouldn't make sense anyway. It's feel weird typing code without the IDE, but that should do the job. So basically, this guy right here is just a hello world class, and let me show you how you do compilings and stuff like that, and then I'll explain to you what each of this guy means. And when I say human readable language, it means that most of this thing will make sense eventually. The combination of all this thing will make sense eventually. And it will just come naturally, I guess. The more you do it, the better you get at it. So what I'll do is I'll save this file. I'll save it in my my class. So I'll name this guy. Remember the actually. There's no save as. Okay, so I'll name this guy the same as the class. So I'll say hello world.java. So remember, the class name should match with the file name. So if I name the class hello world, then the file name should also be hello world.java. So if you're familiar with Python, then this is one of the differences. Okay. So you hit enter, save it. Now you already have the terminal open, right? And does anyone know how to CDs and stuff like that in the Windows or Mac? Okay, so I'm going to navigate to that file. The location of that file, I know where that is, so I'll go CD. First of all, let's assume that I don't know what the hell I'm doing. Okay, so in window, to show all the files, it's going to be $. That's how I normally call it. But it's a directory, short for directory. So you do that in window, it should show you a list of files, and you do pwd should show you the current location. So I'm going to CD into the folders that I save it. Forgot what that is. Okay, so in here you can see that there is a folder, there's a file named hello world.java, which is the file I just saved. And yours should be very similar to this, except for you should have a bunch of other files and stuff like that. But mine just have 3 file. Yours, you should do directory, dir, and then it should give you a list of all the files. So traditionally, back in the day, without the IDE, this is what people do. They write code in the text editors, and then they go to where they are in the terminals, and then they're gonna do Java, C. C stands for compiling, and hello world .java. So if I were to do this, nothing will happen. It just means that there are something. Let me turn on my light. I hate the fact that there's no lights in behind me. Okay, so what you do, if you were to look at the file again, you can see that there's an additional file with the .class extension. So what you did was just you just compiling the file. And the next thing is to execute the file. So what I do is I type Java, hello world, and that's it. There's no .class, .file, or nothing. Just hello world, just the name of the class. So right now you reference to the class name. When you type Java, you reference to the class name. When you type Java C, you reference to the file where you want to compile, the file that you want to compile. And Java means that you want to run the class name hello world. So you do that. It's just going to print hello world to the console or terminal or whatever you call it. So basically, this is what people do back in the day, or at least hackers or something they do on movie. But we don't do that because normally, first of all, it's going to take a while because in any normal real world application, you're going to have more than just one Java file. You're going to have like a couple hundred or a couple thousand files, depending on how big your project is. And compiling this is not really something you want to do. First of all, it takes time and stuff like that. And yeah, it's not something you want to do manually. So you'll let IDE handle it. So remember the reason why we're programming because we want to avoid doing the tedious job or tedious tasks like this. Compiling, executing, and all this kind of thing can take some time and a valuable time actually, because 8 hours a day, you're gonna spend 2 or 3 hours compiling your code, which is what they do in C++ and C# and all of that. So kind of waste of time. So that's why we use IDE, and IDE will take care of all this for us, and we can just run it, and it's compiling, and then it's gonna run. So basically, every time you hit run on IDE, it's gonna do this, and then it's gonna do this. So it's gonna do compiling, and then it's gonna run the file, the class. So I don't expect you to write code like this, first of all, because this is a good practice, so you can keep track of, so you can be aware of what you're typing. Because you see, when I type this kind of thing, as soon as I open a curly bracket or a square bracket or anything, I immediately close it. And I don't leave it open because if you type this without IDE, chances are you will forget to close it. And then you see, I type, I basically just give it a couple of space or a tap or something. And then I'll type my method name. Let's make it some mistake so you can see what it looks like. And normally when I open it, I close it right away, and I can deal with that later. Okay, so when you type code without IDE, there's a lot of mistakes you can make. you can forget the semicolon. And if you do that, let's say you forgot to put a semicolon and a statement, which is a mistake that a lot of people will make when they first start programming. Because first of all, if you use Python, there's no semicolon at the end of the statement. So that's why sometimes you will make that mistakes. And the same thing when I'm programming in Python, sometimes I added a semicolon just because of habit. So if I do that, if I compiling the same file again, you have a compiling error. So this is compiling error. We'll talk about it differs in chapter 2. But basically, compiling error just tell you that there's an error compiling your code. That's why they call it compiling error. And there's a different name for it too. But I call them exceptions. Most of you call them exception unless it's a critical error. But we'll talk about it later, I guess. For now, it tells you exactly what the error is and where it happened. Just like I say, as developers, as software engineers, it's really crucial for you to be able to understand this. Right now, the message is pretty simple, but when you have a really long stack trace with the error, you need to be able to identify where the error occurs and what causes it to happen. Because most of the time, your job is to make sure something breaks and go fix it. So that's why they pay you to be there. And I mean, basically, you look at this error and you go back and then you put a semicolon, you save the file and you recompile it. You go fine. If there's no error in programming, if there's nothing to show, sometimes it's a good thing because there's no error. So let's say in here, you forgot to close the curly bracket or something. You do the compiling again, you see that it tells you exactly where what happened again. It tells you the end of the file that you forgot the curly bracket. So all you do is go back and fix it. So I see a lot of people complain about when they first start in programming and they forgot to close the curly bracket or semicolon and stuff like that. Then one thing you saw me doing is I close the curly bracket immediately as I open it. I don't leave it open because if I were to do this, you'll see that I'll lose track of where I need to close, and that is just not a good thing in programming. In programming, the less error you make, the better. I guess that's obvious, but a lot of people don't get that. So when you do this, you avoid any kind of syntax errors or programming errors or something like that, and it makes you a better programmer actually, and you're actually aware of what you're typing. And yeah, so let's talk about what each of this is. So in Java, there can only be one public class. First of all, let's talk about publics. Public is one of the access modifier, and there's a couple of them, and I think Book will talk about it later. But for now, everything we do is going to be public. Methods is going to be public, public, everything is public. So to tell Java, this guy is the class, we use the keyword class, meaning that we declare this guy, hello world, is a class. And what follow after that is the class name. So so this guy right here, you can name it whatever you want to name it. Name it hello world, name it whatever. You have freedom to name it because this is your program. You name it whatever, as long as it matches with the file name. So this guy right here has to match with the class name. And every time you declare a class in Java, regardless of whether it's public class, private, inner class, outer class, whatever, you need to declare the class keywords before the class name. So this guy right here is keyword, or you recall, that's the reserved word. This is the word that Java understands. They know what class means. And this guy right here is the class name. And this guy right here, everything inside the class. I know this guy right here is inside the class because I know the open curly bracket is right here and the ending curly bracket is right here. So these two matches. That's why I know everything inside of that is a class. Everything inside the class. Yeah, I mean, that's just basic structure of a class. You can have just an empty class. There's nothing wrong with that. You don't have to have anything inside the class. You can just have like this. And you can compile it. And when you run it, obviously nothing will happen. You can run it, I guess. You can execute it, but because you need a public, the main method. We talk about the main method later. But almost everything we do in this class for now is going to require a main method because that's how you run. That's how. That's what we tell Java to execute. That's how Java class is being executed. Execute here is a main method. But for now, there's nothing wrong with having an empty class. There's absolutely nothing wrong with it. It's just you can't just execute. You can't just run it, but you can have it. It's fine. You can compile it perfectly fine. And as you go into work and you know more about Java, you see there's a lot of empty interface. It's just interface with nothing in it. It's called something, but we'll talk about it later when we talk about interface. But for now, just know that this is a really basic structure of a class. First, you need access modifier, the class keyword, and the class name, followed by open curly bracket and close curly bracket. That's all you need to know. That's all you need to create a class. You don't need anything else fancy. Okay, so this is fine. Writing this much of code is fine when you talk about writing in text editors and stuff like that. But when you're writing a more complicated code, for example, you add a little bit. I know the public is capitalized, but I'm not gonna fix it. It's kind of annoying. So you have a little more complicated code. I hate how they autocorrect me. So basically, when you have something that's like a little more complicated, writing code in text editors is not really that enjoyable because you have to keep track of tab and first of all, the annoying autocorrect from the text editors. And you have to make sure everything line up and stuff like that. It's kind of annoying to type this code in IDE, I mean, in the text editor directly. It still works, I guess. If I were to do this. Okay, if I were to compile that and run it, you'll see that it's executing fine. And I mean, obviously the price is 15 because this lady right here is 10, but you have to be less than 10 to get price, half price. But anyways, what I'm trying to say is that like when you write a more complicated code, writing code on text editor is not really the best way to do it. That's why IDE is coming into place. I think IDE stands for Integrated Development Environment. Basically, just another word to say that's an easier tool to write your code in. So you can open your Eclipse. Let's see. Let me see if I can start Eclipse in the blank state. Give me a second. Is it open? It's not opening. Where is Eclipse? I have an older version of Eclipse, I guess, different than yours. Okay, I don't want that. Give me 1 second. Okay, let me start that again. Okay, when you first launch your Eclipse, the very first time, it's going to ask you for your workspace, which is, it's gonna look something like this, right? So, or even IntelliJ, I guess, if you use IntelliJ, I'm not gonna show you right now, but when you first start your Eclipse, it asks you for the workspace. Workspace is basically your projects folder. That is where you store all your file inside a class or inside projects or something. It contains multiple projects, but for now it's going to be just one project in this workspace. But so basically it's just a folder where you keep all your crap in. So I want to name it Sandbox or whatever. Just remember where you put this, because later on you might want to commit it or either get repositories to it or something. So it's the best to know where you put your things are. So normally you're gonna use the same workspace because you can add multiple projects in there. So what I'll do is I'll check this box, use this as the default, and do not ask again. That way is next time you launch the Eclipse, it's not gonna ask you what workspace you wanted to open it in. So you check it, because you don't have a folder, you can always create a new one, but you can do that, I guess. After you've done that, just check the box and click launch. It's gonna open Eclipse. I guess I already opened it before, so I don't see it, but you should see it like welcome page or something like a really something that will tell you that this is something new, I guess, the first time you install it. Does everyone see that? Something? I'm gonna delete this guy. Okay, so you usually see something like this on the left-hand side. There's a two Package Explorer and Project Explorer. Am I getting there yet? Let's see. Okay, let me have this hand on, I guess. So on the left-hand side, there'll be a bunch of options you can select, but I like to go to the menu. So you click on File, and you click on New, and select Java projects. That should allow you to create new projects. So as a developer, the chance of you creating new projects as in your workplace is close to 0. Because they probably gonna hire you to work on existing projects. So unless you're lucky enough to have a new, completely brand new projects for you to work on, otherwise you'll never use this option. I have not used this option for a while. So just click on New Java Projects, name it whatever. In this case, I will just name it Sandbox, I guess. And when you do this, it's asked you for option to use executing environment JOE. Normally, just pick whatever you install it. In my case, it's 12. You can pick 16 or whatever. Now, and after that, just click finish. I guess that should be enough. When you create a new project, it's gonna create that project under your workspace. So you can see right here is where my workspace is. My workspace named Sandbox. Let me change the name to like example or something. Okay, so you can see that my project name is example. That's why in here you can see this part right here where it gray out. It say example. Before that is a workspace name. So that's how you know it's going to create the project inside the workspace that you just created. So click on finish. And if I ask you to create module info.java, just say don't create it. You don't want that right now. So click on don't create. Okay, so now you have a brand new Java project. Okay, so I think I'm going a little bit too deep, but I just want to show you what the differences between coding in IDE and coding in text file editor. So it's fine. You don't know what the hell you're doing because I guess it's always first time. So let's create a new class. Right click on the source and click new and select class. First of all, expand the project because when you create a project, it's gonna look like this. So you can always click on the little icon next to the project name and you can click it, it's gonna expand it out. And you see, hopefully you see the same thing as I do. There will be a JOE system libraries and source folder. This SRC stands for source, like it's called source folder. This is where all your files and anything that you created, class, properties files, and things like that will be in. So you right click on it and click on new class. It will ask you for a name. This is the name of the class. So in this case, I'm just going to call it an example class. Just leave everything the way it is and click finish. Okay, so you notice that it will take you directly to, you can open the class that you just created. You see, and here is an example class. And then up here, you can see that this is the name of the class, example class.java. So when you do that, Eclipse will take care of everything for you. That's the first benefit of it, because when you type code, when you write code in text editors, you have to manually make sure that the file name is the exact same name as your class name. So sometimes there's typo or whatever happens, then it might not always matches, and then you have a compiler errors or something that you might not be aware of. So when you do that, Eclipse will create this for you, and you see on the left there will be a class name example class.java. And I would prefer this style. There's many style, but I prefer this style. So I'll talk about style later. Yes. So right now, you're just gonna blindly type in public static void main string. Right now, you're just gonna blindly type this in. You don't care what it is for now. Just type this in. Just like you did over here, and just type something. It doesn't really matter. Not something, but this thing. You don't have to make sense of any of this right now. I'm just trying to show you what's the difference between typing or programming in IDE versus programming in text editors. So if I do that, I do system.out.println and say hello world. Okay, so there's a couple of things I want to talk about here. Every statement in Java needs to end with a semicolon. You see, every time in Python, you don't have to end with Python, but in Java and other languages like C++ or something, you do need to end with something. In JavaScript too, you don't need to end with anything, but it's best practice to add something in there, I guess. So right now, we're just gonna run this fast. So to run something in IDE, Eclipse, all you need to do is to hit the run buttons right here. There's the little play buttons. I like to call it a play button. You hit it, you click on it. It might ask you what you want to run it with or something. Just select Java application. So if they ask you which one to want to run with, just select Java application. If that's a window, mine doesn't pop up, but yours could be pop up or something. Does anyone see that pop up?
For us, I think you have to click the drop down next to the play button.
You can't click directly on the play buttons?
You can, but for that menu to do run as, you click the
Oh.
drop down arrow next to it.
So when you click on the play buttons, it's just gonna execute this file.
It asks for like to save and launch, like so. Yeah, depending on which resources you have open.
Okay, I guess I forgot to mention that. So first of all, make sure you save your file often. You see, I got a habit of like every time I make any changes, I click Control S on your Mac. I mean, on your computer, on your Windows, or you can just go to File and click Save. You do that, and you see like there's no more asterisk. So if I were to make a change to the file, you see there's an asterisk in front of the class name up here. Yours should do the same thing. In here, there should be an asterisk, and it means that you have an unset file. The file is unset, it's not saved. So what you need to do is go to File and click on Save. As soon as you do that, the asterisk will be gone, meaning that the file is now good to compile, I guess. So hit on Run again, you see that it's print out hello world, and there's no compiling there. Okay, would you want to repeat, Nicole? Okay, so the asterisk part is if I were to make any change to this file. So let's say instead of say hello world, I change it to hello me. Can you see I just changed hello world to hello me? And as soon as I do that, can you see there's a little asterisk on the top, on the left of the file name? Can you see that? All right, so you need to save the file first for that asterisk to be gone and for you to be able to compile and run the file. So you have to save the file. So click on File, Save. And now you can see the asterisk is gone. So that way you know whether you have changes that you need to set, because the last thing you want is to write a bunch of code and then you forgot to save it and your computer crashed. And then you have to explain it to your boss. Just like you write essay, so spend the whole night writing an essay on Word document and you forgot to save it and then computer crash. You have to explain that to your teacher, the same thing. Except for that, the teacher may forgive you, but your boss may not. So don't do that. All right, so to run this file, all you need to do is go on the top. There's a bunch of buttons on top. Click on the play buttons, the button that look like a play on your, if you have a DVD player or something, it look like that. And you hover it, it's even tell you to run example class, run the class name. So you click on it, it should run the class. So if I click on it, and can you see on the bottom is there's a little tab called console down here. This is all the output of the application, whether it be logs or print statements or errors or anything. Anything that your program generated, it will be down here. It will print out exactly what you print out. Later on, I'll show you a little more stuff in there, but for now, just know that every time you do a system.out.println, it's actually print to the console. I can guarantee you that when you go to the real application, you will almost 99.99% of the time, you will never use this guy. you never print out anything directly to the console. Never, even testing or whatever, never do that. It just make you look like a high schoolers or someone that doesn't know how to program, or someone that doesn't worth the money they pay you for, basically. So right now for our class, we use this a lot, system.out.print ln. This is L. It looks like an I, but it's actually an L. To output the data, to output whatever we want to output into the console. So every time I refer to console, I'm referring to this guy right here. And this is where the output is going to be. So you run it, it's output to here, the console.
I'm getting an error message when I try and run mine.
Okay, let's see what your error. Do you mind sharing the screen?
Sure. Can you see it?
Yeah, I can see it. Can everyone see it? Okay, so this is a good example. First of all, delete the module /info.java. Right click on it and delete it. Okay, that was the issue. So can you see right now? Can you see? No, don't run it yet. Can you see on the left of the class name? No, on the tab above the public class. Can you see? There's example.class. Yeah. Can you see a little bit above on top of it? Can you see a little asterisk next to it?
Mm-hmm.
That means that your file is not saved yet. So
okay.
Yeah. Save and then run the file. There.
Okay, cool.
So if you do have a module class, then just delete it. We don't need it. I don't even know what the heck that thing is for. In there.
I don't know where that came from either.
Yeah, so I think when you first create the project, you have to uncheck the create module or something.
Okay. Cool.
Cool. Anything else? Anyone else have problems?
I think I have a problem pretty similar to that one, but I might have missed a step or two.
Okay.
Here,
Yeah, share the screen.
Alrighty. Let's see here. Can you see it?
Yeah.
Alrighty. So I was having some trouble even installing it, so I might have missed a step. But what do
Okay.
I?
So the first thing we want to do, let's delete these two projects. Will you mind delete them projects? Right click on the projects. Let's create this project from the beginning.
All right, let me just get rid of these then. Delete.
Oh, wait, check the box. Cancel it.
Oh, sorry, hold on.
Yeah.
Delete.
So when you want to delete something completely, you want to delete, but don't do this if you have unset thing. But let's hit continue. In this case, it doesn't really matter.
All right, just save and
do the same thing. Yep, do the same thing there.
Alrighty.
Okay, so let's file, new project, Java project. Okay, let's name this project whatever you want to name it.
Just do sandbox.
Yep. And can you see a module on the bottom? There's a checkbox. Create module info Java. All right, uncheck that. Let's finish. Okay, expand that. Right click on the source folder. Yeah, every time I refer to source, I'm talking about the folder name SRC. Yeah.
Oh, got it. Alrighty.
Yeah. Then click on new.
New.
Class. Okay, let's name this class whatever you want to name it. But the first letter has to be capitalized. That's the convention.
All right, let's just do project.
Okay. Finish it.
Finish it. Alrighty.
Okay.
Okay, I got it. Here we go. Now I'm all caught up. All right.
Cool.
Thank you.
Yeah, and just type main static or whatever that method is in there. It should be fine.
Alrighty. Cool. Thank you.
Cool. All right. Anyone else have problems? Where's my screen? Okay. Okay. So the reason, I mean, as you can see, every time you hit enter in Eclipse, it's automatically indented for you. So you can see I didn't even tap or anything. It just indented. So this is the what I call it styling, because imagine if all this guy look like this. If all those guys, if the whole file look like this, and there's a bunch of code, probably first of all I'll fire the guy if the class look like this, because there's no way I can read this guy. At least I mean I'm kind of cheating because I can format this guy, but first of all it's telling me the guy doesn't know how to program. Second, it's really annoying to see this. So every time you have this, you can always go source format. It will do that for you. But technically, when you hit enter, it should Eclipse or IntelliJ or JetBrains or whatever will automatically indent for you. So the more you do this, the better you get it. But just remember, everything inside a class has to indent once. Everything inside this, every time you have anything inside the curly bracket, you have to indent it once. So you can see in here, I have this guy right here and this guy right here. So I aligned everything right here. And then I have this guy, where is it? This guy right here and this guy right here. So I aligned everything inside this guy. So you can see the pattern right here. Every time I open a curly bracket, I close a curly bracket, I tap in once. So it keeps indenting and indenting and indenting in once. Right now, I don't expect you to get it 100%, but just remember, do your best when it comes to formatting. And this is the reason why Eclipse is, or any kind of IDE is better than actually typing raw code like this. And what else I want to talk about? Oh, yeah, debugging. There's a thing called debugging. The reason why they call it debugging is people normally use debugging to solve to fix the bugs or defects or whatever you call it. So debug means just remove the bug. So the way you remove the bugs by debugging. So kind of confusing, but I'll show you how to debug it, because I will tell you half of my time is debugging and putting breakpoints and how debugging fix the issues and stuff like that. So debugging is a really important knowledge that every developer should be able to master. It's pretty easy as the more you do it. But for now, just know that we just created the first class. Basically, this class just prints out hello me. Every time you want to print anything to the console, you use system.out.println. And everything inside that should be enclosed inside the double quote. And we'll talk about what these are later. But for now, just know that everything inside the system.println has to be enclosed inside the double quote. Yeah, so another benefit of doing this using IDE is there will be a millions files in there, and the last thing you want is to manage them manually. Any other question about this? For now, don't feel discouraged or scared or anything, because this guy right here is just basically this is your first program, and there's a lot of things in here that doesn't make any sense, and then it will make sense eventually as we go forward in this class. Any question? And one more thing in this class, I'll try, I guess after you guys get a little bit more comfortable halfway through, I'll try to use Git repositories. This is not something they mentioned in the book, but as a developer, you need to create some kind of portfolio, just like an artist. You need somewhere to show off your work, and things like this. You can add it, you can push it to repositories, and then when you go interview or get a job or internship or something, you can always point them to that Git repositories, and then they can look at your quality of code, or basically just a way to prove them that you've been doing some coding, basically. And I think that's it for Eclipse and IDE. So this is our first programs, and yeah, it's pretty simple, but there's a lot of things in there that might not make any sense, and it will eventually, hopefully, but for now, it does not. Any question before we move on?
I might have one. What's the main difference between a package and a class exactly? And like
Okay,
what
so-
cases would you use a package?
Okay, so good question. And I think we are going ahead, but I will explain anyway. Package, basically, let's say I'll create a package, okay? I'll create a package named Fort. Normally, the package name is always, I'm just gonna type. So this is the package, okay? This package name Forge.example. This is the name of the package. And let's say I have another class inside this package. So think of package as like a subfolder. So so can you see I create a class inside the package or .example. If I were to open this inside the folder explorer or finder in Java, in Mac, what the hell am I? Well, I don't want to show you guys what I have. Okay, can you see I'm inside source folder? This source right here is this folder right here. You see that? And can you see example class.java does not belong to any package. That's why you see it directly inside this folder. And you see the person.java belong to or.example package, meaning that there are two folders exactly, or, and inside or, there's another folder named example. You go in there, you see the person. So basically this package, every time you do a dot on package, it just means that that's a subfolder. So or.example, meaning that I create an or folder, and then inside the or folder, I create another example folder. So can you see this thing matches with this too?
Yep, I can see it.
If I were to create another folder named or.package dot another package, guess what? There will be another folder inside example named another, right? So basically just think of packages as like folder, basically. They're
So
just subfolders.
So is its main purpose like just organization, or does it actually impact how a program works?
It's both, because the thing, imagine you have like, just like I said, you have a project can have up to a couple thousand classes, depending on how big it is, right? And if you were to put everything 1,000 file inside this source folder, imagine looking for that file is gonna be a nightmare, right? And if you, yeah, it's not really good practice. Plus, see this keyword publics? This is going to drive visibilities of this class person. So these packages will affect that based on how secure and stuff like that. But basically, I mean, I think I'm going too deep now, but basically just think of packages as a way to manage, to categorize or manage your files or whatever. Just what did you say? Organize your files, your Java class.
Perfect. I appreciate the explanation. Thank you.
Yeah, I think it's a little bit. We'll talk about it later, but for now, just that's the way it is. Sorry if I make it too technical, but
No, you explained it perfectly. It really helps.
any other question I might be able to answer? Okay, so comments. Java. Comments is what makes whether you people like you or hate you in your workplace or anyone that work with you. Because if I were to write a program without any comments, and let's say you take a break, coffee break, 10 minutes later, you come back, you will have absolutely no idea what you just wrote. And I'm not kidding, that's actually does happen. Because right now, I mean, things like this making much, like you don't need any comment basically. But if something normally in a real world application, the application is gonna be like 20, 30 lines for each method. And you can have like hundreds or thousands of methods. And to know every single thing and every single logics or every statement what it does is almost impossible. I can write this class sandbox right here, but I'm not gonna touch this class until a year or a couple months later. And by that time, I have absolutely no idea why did I write tax rate equal to 0.07. I have no idea. Don't think that you will remember it because you won't. So it's always good to add comments in Java or any languages or anything you do, always good to add comments in there to explain additional stuff. So comments are ignored in Java. So I can type as many comments in there and it won't affect any functionalities or logics or anything. The only reason why you need comments is for people to be able to read your code and understand why you do certain things or why this variable is here and why this variable is that, and anything that require additional information or clarification. And even when I write my own code and then I went to take a coffee breaks for like 30 minutes, 15 minutes, I went back and I forgot what I just wrote. And things like that will happen. And doing this will help yourself and make people appreciate the code you wrote. Because the tax rate is 0.07, but I mean, when you look at this a year later, or anyone else look at this and they will question, the first question I ask is, why do you set the tax rate equal to 0.07? That's the first question anyone will ask if I look at this code. And with the comment in there, it makes sense because I don't know what tax rate is. I'm just making this example. But I can say the tax rate is 0.07 for Colorado as of 2021. So I mean, if you in 2025, then you look at this code and you're like, doesn't make any sense. Why was it be 0.07? It should be 0.9 or something. I don't know what the tax rate is going to be, but this is the reason why you add comments in there. And forward slash is used for single line comments, meaning that, oh crap, I opened the wrong one. Wait. So, and forward slash is just a single line comment. So the next line is no longer a comment because this forward slash only Java will only ignore whatever after this forward slash. Anything outside of this forward slash, Java will not ignore. So you want another comment, you have to add another forward slash. And there's a multiple lines for our people call it block comments. You normally type forward slash start and type whatever inside and then close it with start forward slash. So I can go in here and I can do this. Eclipse will do that for me, but every time I type something, hit enter. You can add many things in there you want. So this is the benefit of using Eclipse or any kind of IDE. We'll take care of comments for you. So sometimes comment won't fit in just one line statements. So that's why you need multiple ones. Yeah, so it's good. It's best practice to add comments as much as possible, but don't over comment it because they can make the file longer than necessarily. Yeah, so try to add comments. I guess that's the bottom line. Any question on the comments?
There's a question in the chat.
Oh, I didn't see the chat. Just yell it out because can't see. Let's see. When you're looking like in a team, is there a specific way you want to correct comment to make sure everyone else understand them? So the rule, the golden rule is doesn't make sense to you. First of all, right? You don't want to write something, write a bunch of crap in there, and just for the heck of writing comments, because your team requirement is you need to write comments. And normally 9 out of 10, that's comment is going to be even more confusing than without the comments. So first of all, you need to read it and be able to ask yourself, does the question make sense? And there's no really any kind of requirements or standard way to write comments. The only reason why you can write comments is to make sure that people understand what that line of code does or why it is the certain way. But there's no way of like saying like, hey, you have to write comment this way. You have to write comments they will follow certain standards or something. There's no standard for comment per se. It's just like whether it makes sense or not. And yeah, I mean, try your grammar too. My grammar sucks. That's why most of my comments, but I try to make it short. So just like people said, the less you do, the less mistake you'll make. So the shorter the comments I write, the less mistake I'll make. Don't include your teammate name in there because imagine it's something like, let's say you have a program, right? This guy, and it broke, and you put your name in there. Guess what? They'll blame on you or whoever the guy is, right? Normally, it's not really good practice to put people's name in there unless you want to specifically blame them later. And it does happen. I mean, when I let's say for a tax rate, right? I don't know where it is, so I ask. Let's say I ask someone at my workplace. Let's say James. I ask James, hey, what's the tax rate? And then he say, it's 0.5. And then I ask someone else, and let's say 0.7. But he insists in that the rate is 0.5. There's no way he was wrong with it. So he's a product manager or whatever. So you go with him. So you say in there, according to James, is 0.5. So if someone were to go back and say, where the hell do you put 0.5 for tax rate? It should be 0.07. Then you tell them, hey, James told me so. So that's the only time you put people's name in there. Unless you want to be hated by the team. I mean, technically, you can always see who make the changes, but normally avoid doing that unless you want to see who added code. Because in the work in real projects, though, there's a thing called Git repositories. That's where you manage your code base. So you see exactly who write what and who commit what and when. So that way you can track who break the code and stuff like that. But normally people don't use it to find who break the code. They just want to find who wrote it so they can get more information from them. Any other question? Like I said, I'll show you how to use Git. So I guess you can find internship or something easier. Okay, so like I say, there's errors and exception in almost every programming language, JavaScript, C#, Python, everything. Java is not an exception, so it has errors and exception. So in the book, it's explicitly referred as errors, but in real life, I mean, or in industry or whatever, they don't just call it errors; they call it exceptions. There's a difference between exception and errors. That's why I don't like to use the word errors every time I talk about something happening with the program, because errors is something that I mean, we haven't talked about try or catch or anything, but just knowing that errors is something that happen to the computers or something or server that we can't do anything about it. Besides restart a computer. So let's say you use up all your memories, and the only thing you can do at that point is to restart the server. There's nothing you can do when this memories is running out. But exception is something that you can control and you can handle. So there's a section or chapter somewhere in there that's talking about handling exceptions and stuff like that. But just know that exception, there's a different with exception and errors. They are not the same. I mean, they are kind of same, but when you talk when you have a conversation with someone, when you say errors and exception, that will be distinguished there, and it can cause some confusion. Yeah, so later on we talk about there's two type exception. There's runtime and then compile time exception, and it's not that complicated, but we'll talk about it later. Just knowing that there's a thing called errors and exception.
I do have one quick question about exceptions. This will go a little bit into error handling, well, exception handling, but just, is it better to deal with exceptions broad, or is it better to give people specific information when they hit specific types of exceptions popping up?
Typically, the more specific the exception, the better it will be, because there's a different way to handle exception based on what exception that is. I mean, you don't want to throw everything as a generic exception, because that way, first of all, you're gonna handle, you can't tell what the different exception and where it happens and stuff like that. So it's kind of hard to handle it. So
got it.
Yeah. So be as specific as possible. Yeah, I don't want to confuse the class. So I'll talk about that when we get to the point where we talk about handling exceptions. Okay, so I think I already show you different exceptions. For example, when you forgot semicolon, you know the Eclipse will complain about it, and there's a red X right there. So that's why we use IDE or any kind of Eclipse or IntelliJ or something. So there's no way you can make a mistake while writing using IDE. I mean, you can make a mistake, but it will tell you right in your face, screen in your face. So that exception, there's an error or something. So when you click run, I need to save this first. Okay, when you click run, it's even tell you right here. I'll tell you there's an errors or where. Even tell you there's an error existing in your projects. Do you still want to run it? So it will not just tell you there's something wrong, it will ask you, really want to run it. So you really want to ignore it, you want to proceed with it. And then you see this guy. So this is compiling error because it caused the program, it caused the application from compiling. That's why they call it compiling error. But we'll talk about it later. But for now, just knowing that using the IDE will eliminate 90% of the time, 90% of the issue you might have if you don't use it. Yeah, I don't want to go too much into exception and error right now. But just knowing that using Eclipse or something will catch this exception. So that's why when you write code in, and then you're gonna submit inside these Replit, you want to make sure you write in, I would prefer to write in IDE, Eclipse or something, and then I'm just gonna copy and paste. So if I wanted to, I can just copy this and paste it and run it. Should be able to. I mean, obviously it's gonna fail because this guy is main and this guy example, so I can just change it to main and run it. So for your projects, just write on Eclipse. Get used to writing on Eclipse because I mean, first of all, it's gonna get used. So when you go to work, or if you're fortunate enough to get a job in this field, then you can always not feel like left out or something. Oh yeah, I already covered the Eclipse. So I think I already hit all these points. Okay, any other question on chapter 1?
It's not a question on chapter 1, but more kind of just a question in general. Can I ask that now?
Yeah, ask it.
So just will we be using Replit for any of our homework assignments, or is it going to be like a different system?
You say applet?
Replit.
Replit?
Little,
Oh,
yeah.
Replit? Oh, okay. I don't know how to pronounce it. That's why that's why I have no idea what the hell. Okay, so what was your question again? I forgot.
I guess I was just wondering if we're going to use those for any of our homework assignments, or if what we'll be doing is going to be purely on Eclipse.
I'll prefer you to use your Eclipse, type everything you need to type in Eclipse, and then just copy and paste it in here, if you can do that.
Alrighty.
Because I really want you guys to be as familiar with Eclipse or IntelliJ or whatever as possible. Because I mean, this guy right here is not that I mean, where is it? It's not really something you use or you work if you get a job for developers, or even anything that you're coding or something. You don't code in here, you code directly in IDE. So does it make sense?
Yeah, sorry. I was just curious. Thank you.
Yeah, I mean, I can't stop you from writing code in here. Like, I mean, that's your choice. but I'll prefer you to type in Eclipse, or even type in editors, text editors or something. At least you experience with this kind of thing instead of just this guy. But I try to make you guys ready for industrial as much as possible. So when you get an internship or a job or something, then hopefully most of you will become a software engineers or developers or whatever you call yourself. And yeah, so you don't feel like left out or something when you go actually get a job. Okay, any other question? Okay, I think that's all I want to do for today, since we have like 15 minutes, and I don't want to go to the next because I want you guys to read chapter 1 and chapter 2, and make sure you read it. Just so I guess I left a lot of not a lot, but some information that I think is not really relevant or is not worth covering, but you can just get it by reading the book. So that's why. But please join the team and do the assignment whenever you have time. I don't know when is it gonna do. Since this is the first chapters, I was just gonna give you guys until I don't have a calendar open.
Oh, I have a question on some of the stuff that we have to do.
Okay.
So for like the quiz and the reading assignment, for those two, are you gonna put those? Are you gonna have us like submit it somewhere?
Oh yeah, so let me help you navigate around this. Let me log in as students. Where is it? Oh, I have viewers. Students. Okay, so if I go to quizzes, oh, there's no quiz. I think I forgot to publish. Let me public really quick. I think I hit it. Okay, I think it's visible now.
Okay. And then same thing with the reading assignment. Are we submitting those two, or are we just?
Yeah, please submit it. I mean, I'm not gonna grade it. I'm just checking whether you complete or not, because I just want to make sure you guys read it. And I mean, it's actually helped a little bit because if I don't do this, you probably don't read the book. I know, because I was a student once, so I never actually touched a book when I was in college. So.
All right, that's all I wanted to ask.
Okay, so let me show you. Okay, so you go to quizzes. That should be chapter 1 quiz, and How do you start it? I want to read it. I want to start it.
The issue is that it was due on February 1st of 2021, so
Oh.
we can't do it now.
Okay. I was just gonna show you what the quiz looked like. Let me change the date later, I guess. Actually, let me change it now since I still have a little bit of time. Just do your best. Forgot what date it is. Today is 23rd. I'll give you until next week, next Monday to do it. Okay, so you want to click it here, you see the quiz, and I mean, you can open your book, use whatever you want to use, Google it and whatever, just because nobody's stopping you from doing any of that anyway. So just select the answers, I guess. Just yeah, should be a very simple quiz.
And then I think the same is having the same issue, I think, with the other assignment, the US
Okay.
population.
Yeah, let me publish them all.
And this will probably end up happening with all of them, since I think they're all probably going to be set for the last semester too.
Yeah, I don't know why the hell the guy copied it. It's doing that.
And oddly enough, same thing happened with another class of mine for this semester.
Huh. Yeah, because when I copy it, instead of clear the date or something, they actually, yeah, I think that should be enough. Okay, so yeah, there's a quiz, there's a little assignment. This guy right here is basically, you shouldn't involve any programming. Don't write any code, nothing in it. Just tell me what your thought process is and how you do it, how you done it. And is there any question you need to ask and stuff like that. So don't make it too difficult than it should be. And normally I will upload my PowerPoint up here and I will try to upload the video after I finish recording it. And then you can watch it if you want. And it's boring enough, you can always watch it before you go to sleep and then you can make yourself fall asleep. Any other question? Okay then, my last word for today is, I mean, hopefully you are in here for a career in computer science, cyber securities or infrastructures or networks or whatever it is. So first thing I want to say is that you guys in the right field, I guess. You're making money. I guess a couple of years later, you won't make any less than 100,000 a year. So that shouldn't be a big deal. But less stressful job, I guess. I haven't had stress about my job for a while. And yeah, take it serious. I mean, there's no point of paying money and go to school and try to get a career out of something and not taking it serious and then wasting money. I know a lot of people who took college not as serious and now they're paying for it. So just take it as like a job, actually. And that's it. If you need to drop the class, you have until September 6th or something. I don't know. This isn't a syllabus, I guess. But yeah. Any other question before we end the class?
No.
Okay, that's always a good answer. Okay, I'll see you on Tuesday. If just, I mean, not on Tuesday, next week, next Monday, if you're still here.
Thank you.
See you then.
See you.
Thank you.
Have a nice
Adios.
day.
Thanks.
Thank you.